All right, everybody. Welcome to weeks 4 and 5. This week we're going to be talking about methods and algorithms. It's a 2-week module. There's a lot of material in here. I'll go over that here in a second as soon as I log in. Okay, so go to modules, go down here to weeks 4 and 5. It's broken up by material. There's the algorithm section. These are videos from Brian Chapman, who taught this course before me, who I inherited this from. These are pretty well high-produced videos. I think they're pretty good. So there's a few parts to this. The first one is algorithms, which define, it's kind of an abstract idea, but it's basically like, what are the steps you take to solve a problem? Because that's all we do in computer programming is we take an issue that needs solving, we think about it logically, we write down the steps that we can do to reproduce in our program to solve that problem. And then there's formalized ways in which we go about that. And Brian talks about a few of those here in these videos. These are pretty good videos. And once we have the algorithm sort of defined in our mind, Brian talks about doing it in pseudocode, which is basically just plain English. How do you solve this problem? And you write down the solution in plain English. The next step to do would be to sort of put that into a chart form, into flow charts. There's lots of different ways you can do it. We're going to use flow charts in this class, and I have a few examples on that, and there's another video for flow charts. And then the final thing is, now that we understand the problem, we understand the steps we're going to take, and we've documented it, how can we implement that in our Python code? And to do that, we would start using a new concept called methods. And then that's what this video is going to be on here, is on methods. And then this last section here is, what do we need to do for this week? What's the homework for it? So we got the quiz, the discussion, and then the homework is in 2 parts. There's quite a bit to this week's homework, which is why it's going to span 2 weeks. This is weeks 4 and 5. So you have 2 weeks to do all this. So this video is over the methods. So if you haven't watched the other 2 videos then yet, you should stop this video, go watch those other ones, and then come back to this. This should be one of the last things you do in this module right before you do the assignments. Okay, so I'm going to copy this code and then go put it in our VS Code. Okay. And let's just top to the top here. Okay, so I'm assuming you've watched other videos at this point. So hopefully there's not going to be any spoilers or anything. So the idea here of methods in Python is we're building up our toolbox. In the past weeks, we've learned how we can selectively execute pieces of code using if conditions, meaning we'll execute one block of code or skip a block of code, and that way we can define what pieces of code do or do not get executed. We also looked at loops, which lets us execute the same amount of code multiple times, as many times as we need. But now we're going to look at a different thing, a different concept here on line 7. It's what do we need to, or what can we do if we need to use the same piece of code at several different locations within our program? And this follows one of the main tenets of programming, which is you should never, under any circumstance, duplicate any logic or code. If you write it once, that's enough. You should never write it multiple places in your code. And so we're going to start using methods, and we're going to see how we can do that. I'm going to start with some clunky code, starting here on line 19. We're going to get some clunky code, and then we're going to sort of slowly work on refactoring it and cleaning it up using methods. Okay. And so again, methods are nice and handy. They let us use the same logic in multiple places throughout the code. That's going to let us avoid duplicating in our code. It's also going to help us, not quite yet, but it's going to get us on the right path to letting us share the sweet fancy code that we write with other developers who might be interested in what you're doing. We're doing that a lot already, right? Anytime we import code, like through datetime or NumPy or whatever, that's code that other developers have written, and they've shared it with us, let us use it, and We too, as developers, have the ability to share that code, and methods is one of the things we need to do that, but there's more to it than that, but we're getting on that path. And then again, methods let us just write the code once and never again. So that's the whole idea here. So we're going to consider these next lines of code here. We're going to start with this, and then we're going to clean it up a little bit. So I'm just showing you sort of without the use of methods. The code we are going to write here is a little bit clunky and repetitive, and then we're going to start cleaning it up using methods. Okay, because that's a tool we're just about to learn, and we haven't yet. So let's say we start with the dictionary of patients. These are the same patients you've probably seen on all the other videos if you've watched them. I just keep carrying it forward because I'm lazy. It takes a long time to write all these codes and data things, so I like to reuse them where I can. Okay, so we're going to loop through this list of patient dictionaries. I'm going to grab out, each time I get a patient, I'm going to go look for their age, gender, height, weight, and name. I'm going to pull them out. Since they're dictionaries, I can just pull them out by name. And then for this example, we're just going to calculate the BMI, and then we're going to print some message to the screen based off that BMI. So the BMI formula is kilograms over meters squared. So to calculate the BMI, I grab the patient's weight, which I just did here on line 39. I take the height. This height is in centimeters. It needs to be in meters. So I'm doing a little conversion there, divide by 100. And I'm doing the poor man's way of squaring, where I just times these two numbers together. I didn't want to have to go import another library to do like math.pow or something, which also would have done it. Anyways, is the cheap, easy way to square something. So I get a BMI weight, or sorry, a BMI. BMIs are going to be some sort of number, usually between, I think, 18 to like 33 is a typical range. And then here, so I've got a BMI. I know the patient's age and gender and all that jazz. So I'm going to start doing some logic, right? So I'm going to say if you're a geriatric patient and you're a male, these are the thresholds. I got these thresholds from the CDC website. So these are the thresholds. And it says if you're over 30, you're going to be obese. If you're in this range, you're overweight. If you're here, you're normal. And if you're here, you're underweight. And of course, there's edge cases, right? What do you do if you're like a 0 or whatever? I don't know. And then the numbers are slightly different for females. They are allowed more weight. So, you have to be over 33 to be overweight for a lady. And then again, these ranges are just slightly different between male and female. Okay, and then what do we do if you're an adult, meaning between age 18 and 65? What do you do if you're between 2 and 18, meaning you're a child? And then what do you do if you're less than 2? And I only put this in here because this is honestly where I've spent like the last 3 years of my life, is working for the NICUs, working on growth charts and BMIs for premature children. That's what these little comments are for. I just wanted to give a shout out to the Fenton and the Olson growth curves, which are special just for premature children. Okay, so we have all this logic, right? It sort of keeps repeating there. And you can see there's lots of different ways that this code is being duplicated. First of all, the messages that we're printing for every level are pretty much the same, right? We're saying these messages, meaning these print statements, these are duplicated, right? We have the obese, overweight, normal, obese, overweight, normal, obese, overweight, normal. And all we're doing is throwing in their names and their BMI. That's highly repetitive. Also, the conditions we're looking for are very repetitive, right? All the females are the same, basically between all the ages. And then all the males are all the same between all the ages, right? It's a lot of repetitious code going on here, but it's what we need to do with the current tools that we have. Okay. So then the question is, looking at this code, it's not great. If you were a professional programmer, you probably wouldn't have a job too much longer if this is the kind of code you're producing. It's pretty unmaintainable, right? What if a change came from the business? One of the doctors said, I need all of my overweight patients to have a different message, right? I want to do something very special and different for overweight patients, and I want it to be this thing, right? So now you got to go through your code with what we've written here. And how many places are you going to have to go update to give that new message for overweight patients, right? There's a lot, right? We've got in here at least, 1, 2, 3, 4, 5, 6, 7, 8 different times. 8 different places we would have to go update in our code to meet this requirement. Or what if the CDC came out and said, you know what, we're going to change the ranges now. America as a whole is just getting fatter. So now in order to be overweight, it shouldn't be a 30 for men. It should be a 33 for men, or whatever the case may be, right? And if we do that, again, we're going to have 8 different places in here that we have to go and update it. And it's really poor code. It's not very maintainable, right? So the idea here is we're going to use a method. Yeah, and just pointing out, I was trying to make sure I wasn't skipping ahead here. One of the main tenets here of programming is that we should never duplicate logic if we can help it. Okay. So anytime you say anything repetitious or duplicated, it's bad code. Okay. So we're going to use methods to clean this up. But before we can do that, we have to learn what methods are and how to make them. Okay. So to build a method, we're going to use this def keyword, stands for define. We're going to go define something, and then we give it a name, and then we give it parameters. So here's a very simple one, right? So we're going to define a method. When you create methods, it's usually sort of like verb-ish, action-oriented things, like what are you actually going to do? So in this case, we're going to calculate something. We're going to calculate BMI. That's our verb, our action. That's what we're going to do. And then on methods, we have to use parentheses at the end of them. Parentheses are where we can give parameters to it. So think about if you've taken calculus before, honestly, or just like linear algebra. When you have functions in math where you have like f of x, and then you just substitute that x, right? You'd say f of 1 or f of 2, f of 3, right? So that 1 or that 2 or that 3 are the input into your function, and then you're going to do the calculations on your function with that number given to it, and then it's going to produce some result. So literally, if you can think of a function in math, that's exactly what methods are in programming. Now in this case, I'm not passing anything into my method or my function. If you want to think about it that way, it's empty, but I have to have these parentheses as placeholders. And then we end it in the colon, just like we do with the if statement, in the while statement, in the for statement, you know, is when we're doing loops and stuff. We have to end those in colons, and then whatever code is indented underneath it is what that method is going to execute. In this case, if I called calculate BMI, all it would do is print out a statement saying I'm going to calculate BMI. So I showed you this not because it's useful or helpful, but because it's the most bare bones basic thing a method could look like, just to sort of level set you to see what we're working with here. Okay, so now let's work up a little bit. Let's make this method that we have started here a lot more smart. It's also going to look a little bit more complicated, but it's basically the same thing. We're going to start with a def, meaning we're going to define something. We're defining our method. This time we're calling it calculate BMI2. We're calling it calculate BMI2 because with methods, unlike variables, they have to be distinctly or uniquely named. So I couldn't have had another calculate BMI in my code. It would have some issues with that. So I'm just calling it number 2, just for simplicity's sakes. Okay. And then again, I have my parentheses, which are required. But this time I'm going to be accepting in some parameters to it. I'm saying in order to calculate the BMI, I need you to first pass me or tell me how much the patient weighs in kilograms. And then I use a comma to separate my parameters. And then the second parameter I'm looking for is what's the height of the person in meters. Okay. So just like again, math with our functions, f of x, we would pass in like f of 1 or f of 2. That's the same thing. We're going to pass in weight and height for our function or for our method before it can do the work it needs to do. And then here it just starts doing the math, right? Weight over height squared. Maybe kilograms over meter squared. That's how you get BMI typically. And then we're just printing it to the screen. Are you guys with me so far? Okay. I got this pro tip. I'm going to come back to that in just a second when I start executing the code. I'll show you a little trick we can do. Okay. So we got this method. We're giving height and weight to it. And then we're going to do something to calculate it, and we're going to print it out to the screen. So now that we have a method, the next logical question is how do we use it, right? How do we invoke that in our code? And quite simply, like here on line 179, we just call the name of the method. It's called calculate BMI2. So we just say calculate BMI2, and then we give it parentheses. And and then we pass the data in there, right? So this should be sort of analogous in your mind to something like this, where we have the method, and then, or we actually give it some sort of value, right? Oops, not that. Something like that, right? We just pass in parameters into our function, into our method, and then it's going to churn on that work and produce a result. So let's run this. Okay, so we're right here on line 181. We come to this calculate BMI, and we see we got 100 and we got 192. And that is actually centimeters. We need that to be in meters. So let me change that really quick. That'll be better. Okay, let's run that again. Okay, so here's the pro tip, right? I skipped over that before. But when we're debugging methods, what we've seen in the past is I would just hit F10. F10 is to step over something, and that's worked up until this point. Now that we're dealing with methods, we're going to need to use the F11 key when we're debugging. F11 is going to jump us into another piece of code to see what's happening to it. See right here, so we have step over is what we've done in the past, which is F10, this little button right here. But now we need to start doing F11, which is step into. And so let me show you. Right when we hover, or the execution, this yellow block is showing that we're right here about ready to execute this. I hit F11, and what's going to happen is that yellow line of code is going to jump up right into our method we defined. Now when we hover over our method, we say, oh, okay, he gave us a 100 for kilograms, and he gave us 1.92 for meters. And I'm going to print out the BMI. And right here. So 27.12 something something. That's our BMI. Easy, right? That was a pretty simple method, and that's how you call your method, and that's how you can debug your method. Okay. The problem is when we execute methods and we write methods, we're typically going to want to store the result of that work, right? So when we write this method, like the one we've done here, on lines 162 and 163, we pass parameters into it, and we do some work, right? We're just doing one line of work here, but it could be, 100 lines of work, thousands of lines of work, however complicated our method is going to be. We're going to do all this chunk of work when we call that method or our function. And then we want to hold on to the result of that work, right? We spend a lot of computing time in memory to get that result. We want to hang on to it. We want to store it in memory in case we need to use it later. Whereas the way we have it here, all we're doing is printing it to the screen, and then it's gone into the ether. We never see it again. We don't have a chance to hang on and to grab that result, which is what we'd want, right? We would typically want to, in this case, right, if we've calculated the BMI, we'll probably want to use that later on in our program for other logic. So we just need to tweak our methods a little bit. Instead of using the print statement here, like we were just showing it on the screen, we're going to change that to something called with the return statement. This is the new keyword that you may or may not have seen. We might have used it in the loops, the for and while loops a little bit. No, that was a break. So this might be the first time you're seeing return. All return is telling us to do is once you've done this little piece of work, like this one line we're doing on line 190, we're going to return that output to whoever called us, to whoever invoked that method, so that they can have it and store it in memory, right? So this is literally the only difference we did on line 190. We changed print to return. So nothing's going to be printed on the screen now, but instead we're returning that piece of work to whoever called the method so that they can do something with it. And so now that we've changed the method a little bit, we need to change the way that we call the method. So right here on like 181, you can see that we did this calculate BMI2. And now the only difference here is we have the BMI equals in front of it. So we're saying go create a variable called BMI and set it equal to whatever gets returned out of that method. And I'll change that again. So now let's start some debugging here. Get rid of this one. Hit F5. So now when we do it, we hit F11. Nothing's getting printed here. But if we look right here, we store the result. Now we have a hold of BMI, that 27.12, and we're storing it in memory in a variable, and we can do something with it later on, right? We'll have a lot of logic we'd want to use with that. So that's the quick and easy way that we would want to grab the results. And that's most methods should be returning a result. If you're not returning results, there may not necessarily be a need for that method to exist, is the general rule of thumb. There's always exceptions to that, but it's generally a pretty sound rule. Okay, so now that we have the method, we've created this method, we need to go back and refactor our code that we had way up here, right? These 113 lines of code. We want to go refactor this code and clean it up using the methods that we just learned how to do. And so we're going to look for some of this stuff. Think about in math, right? What can we refactor, right? What do they all have in common that we can take out? And we see a lot of the male and female the gender and BMI checks, right? So all these ranges are all basically the same for all the males and females. And that's repeated all over the place, right? 1, 2, 3, 4, 5, 6, 7 times, 7 or 8 times. So we can refactor that out of there and put it into our method, right? So we start this new method. We're on calculate BMI. This is the 4th iteration here, just to show you. But to do it, we're gonna have to change our parameters, right? So we still have our weight in kilograms. We still have our height in meters, but now we need to know gender also. So that's fine. We can just add a comma and another variable name. Now we're just asking for one extra piece of information, which is great. Now we're still calculating our BMI the same way we were before. But now we're going to start doing something a little bit different. We're going to categorize what this patient is, right? Now we know the height, the weight, and gender. We have everything we need to know if this person is obese, overweight, normal, or underweight. So all we had to do was just go look and see if you're a male. Here's all the cutoffs. And then we're just going to categorize you. You're obese. You're normal, right? Same for the female. Okay, so we're doing a chunk of work in the calculate BMI. But now we have 2 pieces of information that we're interested in, right? Because we want to know not only what is their BMI, but also what is their category, right? Are we overweight or obese? So now we want to return a couple of pieces of information. Up here, we were just returning one thing. On line 190, we were just returning the BMI. But now to return 2 things, that's not a problem. We just put it in some sort of collection data type. I put it in parentheses. This will give us a tuple. You remember tuples are not editable. So this is just saying anytime this method gets called, I'm going to return both of those results in a tuple, and it can't be changed. It's uneditable. So that's what the parentheses are for. We could also do it in other things like a list with the square brackets, right? Or we could put in a dictionary if we wanted, or an array, whatever suits our fancy. I just chose tuple because it's easy. And now this is what it will look like here. We call calculate BMI number 4, pass in the weight, the height, now a gender, right? Because we said we needed to pass in the gender. And then when we grab the result, it's going to look a little bit different. So let's run this code. Okay, so we're right here on number 4. If I hit F11, I'll step into it just to prove we're passing in 100 for the weight, 1.5 for the meters, and female for the gender. Okay, so we calculate the BMI. Oh, 44. These are all made up numbers. I apologize. That's quite a obese person. And now we get to a gender, right? Is this for male or female? This is a female. And then, of course, the BMI is greater than 33 because it's at 44. So we're saying this person's obese. Okay, so we have an obese. And the BMI is 44.4. Repeating. I'm saying return that as a tuple, which we did. And now when I look at this RES, hover over it, we're getting 2 parameters back instead of just the 1. Okay. Great. Okay, so now that we have this nice new method, right, we've taken out a lot of that logic, we've refactored it, we see that it works. Now we're going to go back and rewrite that code. Okay, and this is, that whole 113 lines of code above, it's been sort of refactored, and here's what it's going to look like, right? So we have our method, just like the same one we saw above. I called it number 5 just to keep with our iterations. We still have the same patients, but here this logic has gotten quite a bit smaller. I call for the results, which is going to give me the category and the BMI. Now I'm just looking by age. I'm saying if you're over than 65, print out this. If you're an adult, do that. If you're a child, do that. But the point is, we get these results, and I can just show the first or second item out of it. And it's going to look something like this right here, where it says Carrie is a female, and she is a normal with a BMI of 27, right? Or Matea is overweight with a BMI of 28, whatever the case may be. So this is what we're printing out. Okay, so we've gotten rid of quite a bit of duplication, but we still have some duplicating, right? You can see that this is the same for all of the age groups. It doesn't really change at all. So the final step we can take is to cleaning up our code is we can just get rid of all the age logic since we're not really doing anything different with it. And now it's going to be a lot cleaner, right? We're going to go from right here on line 313. This is our method, same as it was above. I didn't change it. I'm just showing you what the whole code would look like. This is our patient dictionaries. Again, hasn't been changed. And now this is all the code we're left with. We're looping over each of the patients, grabbing out the data we need, calculating BMI, and then we just have one print statement. We're just printing it out right there. So now we went from like 113 lines of code down to like 80 lines of code, probably less. I don't know. Was it 364, 313? So like 50 lines of code. We cut it in more than half. And it looks a lot cleaner, a lot easier to read. There's no duplication of logic. We've refactored the things that were duplicated. We threw them in a method, and then we just wrote our code a lot more cleanly. Okay. Had to get a drink there. Now that we see how to use methods, how to define a method, I should say, and how to call the method, and then you saw how we refactored some complicated code into something a lot smaller and simpler without any repetition. Now let's look at some of the things that we can do just in general with methods. We're going to skip down to line 367 here. And these are just general things we can do. Okay. So when you call a method, you saw it right here, like on line 361. We're just passing the weight, the height, and the gender. And we're passing it like that because when we call this method, let me just show you, we haven't seen that yet. When I say call calculate BMI 6, when I start my first parenthesis, it's going to pop up a little screen here with information saying what is needed to be passed into it. It's saying the first thing we need to do is pass in the weight in kilograms. So I'll just type in 1. And when I hit a comma, it shows here's the next thing it needs. It underlined it. It needs to know the height in meters. And then a comma, the second thing is what's the gender. Okay, so we did that. But another way we could do it is what we got going on here on line 369. 369, instead of just passing weight, height, and gender, we can say what parameter we want to assign what data to. So we're saying go look for the weight in kilograms parameter for this method and assign it to that. Go look for this parameter, assign it that, and this parameter gets that. So the only reason we would want to do this, it's a little more verbose. The only reason we would want to do this are two things. Number one, we want to make it easier to read, just so if we have weird variables going on, like we named that weight, which is pretty clear, but we could have done something more obtuse, like int1, and the user may not know what that is, or the programmer, who comes after you. And so you're just saying int1 is the same thing as weight in kilograms. So that's one thing we might want to do is help, just matching up the alignment, right? What's what variable and where it goes. Makes it easier for us, as programmers to just make sure we're getting in the right place. Another reason we want to use or may want to use this, and again, it's optional, is that the order in which we pass the data in no longer matters. As long as we're specifying the parameters, we can do it in any order we want to do. So let me undo that. So up here, we were passing in the order that the method defined it as, weight, height, gender, right? Weight, height, gender. But now we're saying height, gender, weight. And the order doesn't matter because we're saying this is the parameter that it goes to. And that's all it needs to know. And then it can do the mapping behind to put them in the right order for you. So if it's easier for you to think of things in a certain particular order, you can do that. Just give it the parameter name like that. What we cannot do, just to make sure it's very clear to you, is we cannot do something like this. We can't just randomly throw our data in there, right? Because I'm doing gender, height, weight, and our method says it's height, weight, gender. I can't just throw them in any order I want. I have to put it in weight, height, gender order when I'm calling it this way. The only way I can put them in the order that I want and ignore that is if I give it these prefixes saying that parameter gets this one, that one gets this one. And then that way I'm explicitly assigning them to them. And if that's confusing to you, don't even worry about it. These are optional. You don't have to do it at all if you don't want to. Just do it like the normal way here on line 361. That's the standard way. Just showing you have options, things that you can do that are a little bit fancier. You remember when we did data types in the first, second week, I guess? We could give some type hinting. We could have said, was it age int is equal to 39, something like that. We're just saying we have a variable called age. We're setting it to 39, and we're given a little hint here that it should be an integer. We can do the same thing with methods. So we're sort of hinting, right? So we're saying we have this method. Now we're on BMI calculate number 7. And now we're just giving hints. We're saying the weight in kilograms should be a float. Height in meter should be a float. And then the gender should be a string. And then this last thing, this arrow and tuple is saying this is what it should return. When you call this method, you will get a tuple back. And that's what we're seeing right here. We're returning this parentheses item, saying the BMI, the height, and the weight and stuff. And now when you call it, calculate, what is it, number 7. Now when you look at this description here, it didn't say this before. It just said a parameter. But now it's saying, oh, that's a float, right? It's saying weight in kilograms is a float. So now I know I can go 1.0, whoops, 1.0 or whatever. And now we're on height in meters. This is, oh yeah, that's a float. 2.5. And now we're on gender, and it's saying that's a string. It doesn't tell us what the string should be, but it's just telling us that it's a string. So it's giving hints, and it's saying it's going to return a tuple. So we could do something like this. Just a tuple. Okay, so that's what the type hinting does for us. It gives us a little bit of notice of what kind of data will be should be passed in and will be sent back to you when you call that method. It looks a little bit more busy when it's not necessary to do, but it's sort of like self-documenting code. You can let other people know what it's like. So if you do plan on sharing your code with other developers later on when you get more skills, this is the sort of thing you would do to make it nicer. If you get an unfamiliar developer using your code, they may want to know these sorts of things. And that's something you can do. Some decorating on there. Okay, so something we haven't talked about yet is what do we do when we want to pass a lot of parameters into a method? All we've seen so far is either we don't pass any parameters in, right? We just have the open and close parentheses with nothing in between. We're not passing anything. And then on the BMI examples, we're just passing in 2 things, right? Height, weight, or 3, height, weight, and gender. What do we do if we want to pass a lot of stuff into a method? So we have a few different options that we can do. I'm going to work through all 3 of those with you, and you can see pros and cons of them and decide what would work best for you. Although there is generally agreed upon best choice here. See if you can pick out which one's the best choice or which ones are the less desirable choices. So we're going to switch up gears here. Just going to keep something simple. And we're creating a method called addition, meaning all the numbers that you pass into it are just going to be added together. And then we're just going to return the result of it. So here we're just saying number 1, 2, 3, 4, 5, and 6. So this one is allowing us to pass in 6 parameters. Okay. So if our use case is we want to just be able to pass in a lot of numbers, this is something we could do. This right here has artificially limited us to just 6. We could go berserk and just, play this all the way out as far as you want to go. And then you just have to add them all together. Right, add number 7, add number 8, add number 9. I missed the B there, but so I can just do that, right? And it's artificial. So there's definitely some pros and cons to that strategy, right? Meaning you got to fix a number. It's not an arbitrary number. right? You have to pass in 9 things. This method won't work unless you now pass in 9 things. And that works great if you have 9 things to add, but what do you do if you only have a few things that you want to add together? Oops, I changed the signature, so I gotta do that now. Okay, so now when we call addition, what if we only have 3 things we want to add? Although we've defined 9 parameters, you would have to do something like this. You'd say, add the first 3 things, and then all the rest are zeros, and that would work. You can kind of start to see how this gets to be tedious and unmaintainable and not really a good design, right? It's not very flexible, not really maintainable. It's not a good idea. And it's honestly what we're trying to avoid in programming. We don't want to have duplications of things, and we're doing some duplications of things here. Maybe at a lower level, but it's still not ideal. It's a little clumsy, right? We can do better. One of the things we can do to improve this, if we want to stick with this strategy, we can improve this, right? We can have the same sort of thing, but this time we can give it what are called default values, right here, default values on line 401. And all we do is we say, here's a parameter, and then for all the rest of the parameters, we can just set a default value, meaning if nothing is passed in for those parameters, they'll just automatically get these values. So this helps us, right? We go from having to do this on line 397 with all those zeros to now we're on line 489 where we just have to pass in a couple of things. And if we just ignore the last few items, it'll just assume 0. So it's a little bit cleaner, a little bit easier. That does help make it better using these default values. That's one option. But we have a better idea. We have a couple of better ideas, actually a few better ideas. One of them is we just pass a list, right? A list is already a collection of things, and we don't really care how many items are in a list, right? Or a dictionary or an array or a tuple. They're arbitrarily short or long, doesn't matter. And we already know how to read those things, right, with our loops. So now we create this new method called additions2. We just pass it in numbers. We can give it a hint that it's a list, right? We just say, give me a list of numbers. That's great. And then all we got to do now is we're going to be a little bit more abstract, right? We're going to keep a running total of all these numbers added together, right? So we're going to read one number, add it to the total, read the next number, add it until we're done reading. Then just return the total, right? It's an easy way to do addition. And we don't care how many items are in that list. So that's definitely more preferable than what we're seeing up here, right? We don't want a definite or a finite number. We want to keep things loose and nimble. It requires a little bit more logic on our part, but it's definitely a better result. This is generally considered better. And now when we call something like addition, or addition2 in this case, it doesn't matter how many items we do. We just have to do it in list form, right? So in the parentheses, between the parentheses, it's expecting us to give it a list of numbers. So we just put the numbers in square brackets, right? Because that's what the syntax is for a list. And now we can pass an arbitrary number, right? Here in line 425, we're passing 5 different numbers. And then we're calling the exact same method, doing the exact same thing in 428. And this time we're passing 11 different things, right? And it doesn't matter. It's all going to be the same. So let's just debug that just to show you. Okay, so we got these. Oops, wrong button. Okay. Hover over numbers. We can see, sure enough, we got these 5 items. We're going to loop through them. So our total starts at 0. We're going to grab the first number out of that list. Happens to be a 1. Then we're just going to add it, right? 0 plus 1 is 1. Grab the next number, it's a 2. Now it's going to be 1 plus 2 is 3. And then we take the last number, which is, oh, not the last number, sorry. The next number, which is 3. Add those. Then we've got a 4. Add that. Add that. And now we've read all the numbers, and our total is 15, right? So 5 plus 4 plus 3 plus 2 plus 1 is 15. And we've captured the result right here, right? 15. That's what gets when you add all of the list together. And now, likewise, we can just do the same thing for these, right? I'm not going to go through all of them. But you can see when we add all these things together, using that exact same method, that our result is 66. So easy, right? Nice and flexible. So that's definitely a preferable way of creating the input parameters for our method and just being a little bit more flexible. But we still have another option if you don't like that. And this is actually a Python preferred way. is we can use this asterisk. This asterisk is implicitly converting whatever data you give it into a list. So now we can do, it's the exact same logic. The only difference here is instead of passing a list of numbers, we have this asterisk numbers. That's the only thing that's changed. All that's identical. And since it's implicitly converting it to a list, we no longer have to use the square brackets here. Right, so let me just show you that. We can do the same thing here. We just can get rid of the square bracket because it's automatically going to convert that for us, just like that. And I gotta make that addition 3 because that's our new method. Okay, now if I just put a breakpoint there, let's get rid of these ones right here. Okay, so now addition 3, we come over, hover over numbers. There we go. It grabs the first one. So it's not showing it when you hover over it because it's handling this all on the fly. So we can't get the same sort of IntelliSense or the, not IntelliSense, sorry, the view into it. We can't really peek into it, but it's still going to do the same thing. Right, so our result in that one's 15. And then again, this one should be 66, just like the last one. Oh, too far. But yeah, it's 66. So it's slightly cleaner, and this is the Python preferred way of doing it. I personally like the lists, just because that's what I'm used to doing. But you can do it this way. Okay, so you have a couple of options. And then there's one final option that we can do. And again, this whole problem we're trying to solve is how to send an arbitrary number of parameters into a method. Just like we did lists up here on this example, we could have done dictionaries, right? Remember, dictionaries are just key value pairs, and we just sort of throw those together. By using a double asterisk instead of a single asterisk, it's going to implicitly convert whatever data you give it into a dictionary. So that means you need to give it dictionary-like items. And then we would loop through it just like we did with dictionaries in past lessons, right? We're going to go look for the input parameter. We're going to go look at all the keys. And then we're going to go, see what the value of that key is. And we're just sort of going to print that out. So in this case, instead of passing an explicit dictionary, I'm just passing it key value pairs. And it's going to manually convert those into a dictionary for us. So there's a fake little method called greet patient, where I'm just going to not really greet the patient at all. Actually, I'm just going to iterate and show you all the keys and values. So I passed it this, the ID, name, and age. These are completely arbitrary. I could have passed literally anything here, right? I was assuming this was maybe a patient. So we're looking at the keys. We're printing them, right? So we got first one was ID, second one was name, and the last one was age, right? Because that's what we sent it. And if we look all the way down here at the end of our output, this is what it gave us, right? ID, name, and age. And just to reinforce the point that this is completely arbitrary, which is the whole point of this exercise here, is how do we pass arbitrary numbers and types and quantities of parameters into a method. It's just to show you that this is completely arbitrary for the dictionaries as well. Right here I have passed ID, name, and age, and it doesn't really matter. I passed age, height, and planet here just to show you that it'll work just the same. Right, so output that. Age, height, and planet. So it doesn't really matter. So those are the options that you have if you want to modify your methods to accept parameters. Get rid of this. Okay. The next topic we have to discuss is recursion. So recursion is something you can do special if you're a method. It only works in methods. So let's say we have a method like we've done up here before, right? All of these things like addition, calculate BMI or whatever. And we call those methods, right? Just like we're doing here. But what happens when a method calls itself? And that's where we get into this thing called recursion. It's where it starts to loop in on itself. So here's a quick little example that I put together for you. And we got to be careful with recursion. Recursion is generally considered high class. It's if you can do something in recursion in programming, people generally recommend it because it's a little bit more efficient. But there's some pitfalls with recursion that make it a little bit more, high level functions that we can do. One of them is that you can enter an infinite loop, just like we saw in our for and our while loops. If you don't have the proper conditions or whatever, you can put yourself into a corner where you're getting these infinite loops that'll never stop. Same is true with recursion. We have to have something, right? So we call a method the first time. And then if we're going to call that method a second time, we have to have something that's changing on that second call so that eventually when we keep going and going and going, this has to have an end at some point, right? And it's very easy to get an infinite loop in recursion. We have to make sure that we're doing some sort of tweak that's going to change that so that we will have an exit condition at some point. So let me give you this example I came up with. This is a little trait example. Sorry, it's simple, but say we wanted to read the diagnoses for a patient. We give it a list of patients. And all we care about is a very special case, right? It's does the patient that we gave you have herpes in the list? And this will behave very similarly to the Python condition word in, right? We could have said something like this. We could have said if herpes is in diagnoses. Right, all that would do is return you a true or false. But here, so the way that this in works, we saw this last week or whenever we did the loops. We saw that this right here would just return us a true or false. But the same way that operates behind the scenes is the same thing that we're doing here in recursion. It's going to be the exact same sort of logic where it's going to traverse through that list through recursion or recursively, and then just tell you if that condition has been found or not. Okay, so we're going to read the diagnoses. We're going to read through all the ones they give us. This is the data that we're talking about here, right? We're going to pass in a list of tuples. And so the tuple is going to be the diagnosis name and then some sort of code. These codes are all fictional, obviously. These could be like ICD-9 codes. They could be SNOMED codes, CPT codes. Doesn't matter, right? Link codes or anything. These are the codes. These are the descriptions, right? So it's going to loop through all of those. It's going to look for the first item in the tuple, which is the description, and it's going to see if there's a match. And if there's a match, it's going to return it. But if there's not a match, it's going to take this list of diagnoses that we gave it, right? This diagnosis in, and then it's going to remove from that list the problem that we just inspected, which is the first problem, right? We're only ever going to be touching the first problem in the list. All this code here, we only ever touch the first problem. You see, we're not doing a loop. There's no loops in here. It's only an if condition. What's making this loop is that here we're calling our method again. You can see here on line 478 that we're calling the same method. It's calling itself, but it's passing in this reduced list of diagnoses, I guess. Okay. And then it's also returning. So that's very important. Line 478 is probably the most important. And I'm going to step through this and show you. Recursion does some interesting things when we're trying to debug it. Okay, so here's our method. All it's doing is looking for the first item, see if there's herpes in it. If it is, it returns it. If it's not, it removes that first item, and then it calls itself again. And this line 476 is what makes the whole recursion happen without being an infinite loop, right? We keep removing the first item that we examined. And then by doing that, the list will eventually get smaller and smaller and smaller until eventually that list has nothing in it. Okay, and that's what's going to make this condition, not true or exit the loop at some point. Okay, and so that's our method. Here's our data, all fictional data, obviously. And then here's how we call it, right? Just like we've done before. We say, here's the result, and we're going to store it. And then here we call the method and pass in our list of diagnoses, and then we're just going to print out what the result was. So let's run this code. Okay, so here's our list of diagnoses. There's 8 of them. You can see herpes is the last one, so we do have it. Right here, the last one. So this condition should get hit. It's going to be the last one, though. We're going to call read diagnoses. Okay, So I want to introduce something that we haven't seen or talked about before. So when we're debugging, which is this little debug icon right here, you can click it to turn these on and off. But when you hit F5, this is going to pop up by default. We've looked up here at the variables before where we see what's happening, to our memory items. What we haven't talked about yet is the call stack. We haven't even talked about stacks at all, honestly. But think about a stack is another special kind of collection, just like a list or an array or a dictionary or a tuple. A stack is a very specialized thing, and we can use it in Python. We skipped it because it's a little bit more complicated and we won't really necessarily need it, but it comes in handy here. So a stack is, think about on your desk, you might have a stack of books, right? Maybe you're textbooks for school, right? The very bottom book might be a math book, and then on top of that's biology, and then on top of that's chemistry, right? So that's a stack, right? Technically, think about it in your mind, that's just a stack of books. In order to get to the math book, you have to take off all the items on top of it first, right? You'd have to take off that chemistry book, then you'd have to take off the biology book, and then you're at the bottom, right? You're at your math book. So that's how stacks work. So when we're talking about debugging and computer programming, we have what's called a call stack, and it's going to work the same way. Call stacks, all they do is they keep track. Since we now have our yellow line, see this little executing command right here? This execution, I don't even know what you call it. This yellow thing shows where the control, that's what it is. Your execution control is right here. It's this yellow line. And now that we're using methods, it can hop all over the place in your code, right? It's going to hop from, in fact, it just did, right? It hopped from right here, line 493. You can see here on my call stack, the bottom one, it started here at line 493. When I click on it, it highlights it. That's where it started. But that referenced a method, which was way up here on 473, right? So now we've jumped to a different spot in our code. And so the fact that our execution control can jump around our program is why we need a call stack. It's going to keep track of where the execution control cursor is going in our program. And then once it's done, its job is to go backwards and backwards and backwards until it gets back to the very first item, right? To our math book on the bottom. And that's how it knows how to keep track of where to put the execution control. And when we've done loops and stuff before, we've only ever seen one or two items in our call stack before, right? It might be at the start or the end or wherever of our loops or our if conditions, and that's about it. It's not really going to be hopping around. But now that we're doing recursion, it's going to be doing something quite a bit different. It's going to be executing itself over and over and over again. And so the execution control is going to start adding all of these little books or these little items onto our stack. And we're going to have to start unwinding them or taking those, books off top of the stack before we can get back to where we need to. So watch this call stack and watch this yellow execution control line as I go through this method recursively, okay? So we're grabbing the first item on our diagnoses. We're grabbing the first item in that diagnosis, which is the string. We're looking to see if it's herpes. It wasn't. It skipped over that line, okay? And now we're going to remove that item. So now we're down to 7 items instead of the 8 we started with. And now it's calling itself with that smaller list. See, now when I do that, you can see it added another item to the call stack. It's like, oh boy, you went back up to line 473 again, right? From 478, and then you went up to 473. Now I'm going to do it again. It says, okay, you did something else again, right? You went from 478 back up to 473. Now we got this read diagnosis on here 3 times. Now it's on here 4 times. Oops, hang on. I have to run that again. I didn't have a breakpoint set where I thought I did. Okay, so watch our call stack. It's going to get bigger and bigger until we get... Okay, we finally met our condition. Let me make this call stack a little bit bigger. Oh, it's already max. All right, anyways. So we have this really big call stack. And now we found our parameter, but it's not going to give it back to us yet until we get all of these items off of us, because we have to get back to this line right here to 493. And you see we can't get back to 493 until all the way down here, the very first thing. So even though we found a result, the fact that we call things recursively means we have to sort of get all these books, all these calls off top of us until we can get back to where we started. So now I'm going to have to hit F10. And here's the whole point of why I'm telling you this is if you're debugging, you're going to have to hit F10 1, 2, 3, 4, 5, 6 more times to get the result back to here to give you your parameter. So we hit 1, 2, you see them going off? There we go. So now they all came off. And now I'm going to get my result. Now it says, yes, I found herpes in that list, and here it is. That's the code and that's the name. And then I can just display it. Okay, so that's recursion. It's a little bit more complicated, a little bit more of an intermediate task to do. And it's a little bit more complicated to debug, but it can be done. And that's how you do it. So that's a very small, minor example. Hopefully that helps make sense. You can do the exact same stuff with loops, right? You don't have to use recursion. Recursion is just generally considered to be a bit more of an advanced skill, and it's more smiled upon if you can do it. Okay. Just get rid of these breakpoints. Okay. A couple other things about methods. Just 2 more things, actually. Yep, just 2 more things. One thing is that methods can be nested, just like we did if conditions that were nested, meaning one underneath another. And just like we do with loops, right? You can nest one loop within another loop. In fact, that's a very common thing to do. Methods also can be nested, but that makes for some really complicated processing and logic in your part. And if you were to nest one method within another, the only person who can call that nested method is the containing parent method. And there's very little, I don't know, use or function or utility for that sort of thing. So I'm not going to talk about it in this class. Just know that it's a thing. And if that's something you're interested in, you can go Google that up on your own. None of the assignments or any of the work we're going to do are going to require that. I'm just trying to keep all the noise away from you as I can, so we don't need to worry about nested methods. Just know that it's a thing that can be done. But it is, however, a pretty good segue into this topic of scope. And this will be our last topic. Let me just make sure. Yep. So we're almost done here. Our last topic about methods is scope. And we haven't had to deal with scope yet, mostly because all the scoping has been sort of done automatically for us. We haven't had a lot of complicated logic or anything yet. But now that we're introducing methods, it's something we're going to have to deal with. At least we're going to have to think about it. Okay. So Python has 4 different ways of doing scoping, or I should say 4 different levels of scoping. I'm not going to go over all of them. I'm only going to go over the 2 that matter to us right now. And that's global and local. And these are some pretty simplified definitions here. Scoping is mostly going to apply to variables. It can apply to other things like nested methods, but just we're going to assume variables for this specific scenario. Okay. So the default level of our code, everything is going to be scoped globally. So and a simple way to think about that is if your code is not indented, if it's not indented, meaning it's all the way assigned to left, then you're dealing with global scoping, meaning it's called global because everywhere in your program you can read and write that variable. Okay, it's accessible anywhere. That's what global means, right? Local, on the other hand, only is visible to within that container that it's in. So if you've written an if loop, and inside the if loop you create a variable, that variable is only available in that if loop. Or same thing if a while loop, right? You create a variable in a while loop, which we did a lot, right? Like if we do a count or a tally or something within a loop and it's indented, that's a local scoped variable. And so the easy way to remember that is if the line of code you're on is indented at all, you're going to be dealing with locally scoped concepts here. And so I got a couple examples to show you. And scoping matters, but it can be avoided through smart programming. But if you can't avoid it, you just need to be aware and understand that is what's happening when you start seeing weird results. And so I put together a very basic example of this. Okay, so we have we're creating a method. We're defining one called say hello. You just pass a name to it, and it's going to say hello about that name, right? Pretty easy. So we start with this variable. So here we go, right? We have a variable. It's indented, right? It's not all the way on the left. So this is now a locally scoped variable. What that means is I cannot access this variable of greeting anywhere else outside of this code that's indented, right? In this method. I can't access it out here because it's locally scoped. Whereas this one, ending, this is a variable. It's aligned all the way left. That means it's a global variable, and I can use it anywhere I want. And I do, right? You can see I've defined this variable called ending. I'm using it up here in this method, right? I'm not defining it in the method. I've defined it here, but I'm using it in this method because it's globally scoped and I can do that. I cannot take this variable that's locally scoped and use it anywhere else, right? So if I try to do that, it had to be commented out. It's going to turn red. And I hover over it and it says, there is no such thing as this variable. I don't know what you're talking about, right? And it does not know about it because I am at a globally scoped level trying to get a locally scoped variable, and it will not let me do that. And that's why it's turning red. And that's why I had to comment this line out, right? I'm trying to illustrate that for you. There we go. All the rest of this is fine. So let me just execute this. It shouldn't be too big of a surprise what happens. Okay, so I create this variable called ending, which is just an exclamation point. Now I'm going to call this method called say hello, pass a name into it. So I've passed in Chad. So we start out with this greeting as nothing. And I'm checking to see if the name is Chad. It's going to say hello professor. Otherwise it's going to say hello student, and it adds the ending on, right? And this ending is the thing, right? We're going from global down to local. So the higher level down to a lower level, that's fine. And now our greeting is hello professor, exclamation point. Okay, we can do it again with Shay, right? It says hello student, adds on my exclamation point, and that's great. Okay, and so I can use this ending anywhere, right? I can just print it out. That's easy, right? He's globally scoped. I can use him anywhere. This guy is scoped locally, meaning he's scoped just for that method. I can't use or access that anywhere else except for just this method. And you saw what happened when we tried on 544. Okay, so let me give you a different example. An even more obvious one, I think. This one might be a little bit tricky. Hopefully not. Hopefully we explained that enough. But if this doesn't make sense to you, then pause the video and go through until you understand it. Or perhaps Google up some other resources. If I'm not explaining it well, they might do a better job of explaining it to you. But here's a different one. Okay, and this is one of the last examples we have here. So we're defining a method called say hello to this time. And all it's going to do is say, it's going to create a variable called message. And we're going to say, hi, this is Chad. And then we're going to print that out. There we go, clean that up. And now we have, so this is a locally scoped variable. And so what happens now when I have a globally scoped variable of the exact same name, right? So I have the exact same variable names, both local and global. Okay, and they're showing different messages, right? So this is, hi, this is Chad, and this is saying, no, it's not Chad, right? So they're exact opposites. So I wanted to show you what would happen in this scenario. It might make more sense or less, I don't know, let's find out. Okay, so I have this globally scoped variable called message, and it starts out, we just set it to the default message saying, no, this is not Chad. But now, right, so I put it out to the screen, right? No, this is not Chad. But now when I call, say, hello to, oops, hang on. I didn't step into it. Let's step into that. Okay, so it prints out, no, this is not Chad. Now when I go here, right, so the value, these variables are using the same name, right? Message and message. So before we even start, it says, oh yeah, this variable exists already. And it's already been set right here on line 5G6 globally to say, no, it's not Chad. And I'm going to go change it, right? I'm going to say, oh, hi, this is Chad now. And I'm going to print that. You can see now it's swapped to hi, this is Chad. So we've changed that variable. Okay. All right. So we had the global one, we had the local one. We changed them. They're sharing the same memory address. I changed it in that in that method. So what do you think is going to happen now when I print out message? Is it going to show the global one or the local one? And this is where the whole crux of it. This is where you can start to see incorrect results. When you start writing programs and you get some processing issues or some anomalous results, it's this sort of insidious thing that you really need to understand how the compiler is working to understand why you're getting weird results, right? And this is one of those semantic issues, not a syntactic issues, where we're starting to see bugs. And this is where it can really start to creep up on you, and you got to have a decent understanding of how it's working, right? So when I hit this print message, what do you think is going to happen? It reverts back. It's showing me the global level message, right? Even though I stored it as no, it's not Chad. I updated that variable. We all saw it happen, right? I updated it and said, hi, this is Chad. I updated it. Okay. And then when I came back here and printed it, it reverted. It ignored all that stuff I did there, and it reverted it back to the globally scoped level thing. Okay. And Python's doing that for you. It's enforcing you to do that, enforcing good practices, I should say. We can override that. I don't know if you'd want to. This is not a good practice, but you can force it by adding this line here, 570. It says anytime we're talking about message, I want you to think about it globally, not locally. So we're overriding the local scoping. And so now when we see it, see before it said no, hi, no. Now when we do the exact same code, the only difference is we added 570. Now it's going to say no, hi, hi, right? So that's the difference. We globally scoped it and it changed it. Now it operates how you might have thought it was going to, but that's very poor practice. So it kept the local scoped changes, but by default it won't do that. Okay, so that's probably a confusing way to end it, but that's all the topics or all the concepts we have to talk about for methods. So I hope you take that into account when you start doing your assignments, which we'll talk about, shortly.